Okay, guys, this is exam 2, question number 3. Prove that the difference of any even integer minus any odd integer is odd. As usual, I will start my proof with an aside, and I'll just write down everything I know about the problem. Right? So the difference of, okay, so we have an even integer, an odd integer, and we're asking if the result is odd. Right? So I'm just going to choose letters for this. So I'll let my even integer be m. And I know since it says even, I know that has to be equal to 2k for some integer k. Okay? My second integer is odd, so that's n equals 2k plus 1. Or not k, sorry, I'll use L. Don't use the same variable in your definitions. So that's 2L plus 1, where L and N are integers. And I'm asking if the difference, i.e. m minus n, is odd. Well, again, I'm just going to set this equal to whatever. I'll use p. So 2p plus 1. This is what I'm questioning. Okay? So all I'm going to do is I'm going to plug in my value for m, plug in my value for n, and I'm going to see if I can get this form 2p plus 1. So m minus n is equal to 2k minus 2. Let me put parentheses around that. 2l plus 1. And that's equal to 2k minus 2l minus 1. Okay? I'm looking for a plus 1. So what I'm going to do is I'm going to group the 2k and the 2l together. Yeah. So I want plus 1 on the outside of this parenthesis. So how do I get from plus 1 to negative 1? Well, I subtract 2. Because minus 2 plus 1 is negative 1. I notice that I can factor out a 2 out of the parentheses, so I get 2k minus L minus 1 plus 1. And finally, that is equal to 2p plus 1, where p is equal to k minus L minus 1. So this is how I'm going to prove it. Right? And so here's the proof. Let m equal 2k be any even integer for some integer k. Let n equal 2l plus 1 be any odd integer for some integer l. Therefore, m minus n, and I'm just going to do exactly what I did before with my algebra. Replace m with 2k. Replace n with 2l plus 1. That's 2l plus 1. So now I'm going to distribute the negative. That's 2k minus 2l minus 1. I'm going to group these two terms like I did before, 2k minus 2l. And I want a plus 1 on the outside, so I have to subtract 2. Then I can factor out my 2, that's k minus l minus 1 plus 1. And that's equal to 2p plus 1, where p equals k minus l minus 1 is some integer. We can conclude that m minus n is an odd integer Thus, the difference of any even integer and any odd integer is an odd integer. QED, we're done. That's it, guys.